Hi, this is Stephen Brower from Raton Valley Community College. This is for the data structures class. This is part 2 of the lecture. Part 1, which went through introducing what recursion is. This part 2 will show recursion on an array. Part 3, which is yet to be created, will show recursion on a linked list. The idea of using recursion in a data structure is that we kind of want to take the structure and breaking it down into a smaller piece. So if we're looking for something or trying to figure something out or doing something with the data structure, we can go with smaller and smaller parts of the structure until we come up with a single value. So if we're using an array, we could break the array in half as an example and deal with one half and then deal with the other half. So with the merge sort we're going to take a look at here, we actually can have, let me jump forward and come back. So the merge sort, let's do this. So the merge sort method here receives, remember in Java, it's a reference to an array. So it's not the entire array is being copied, it's the address to the array is what's being passed. And then saying where do we begin in terms of this array and how many pieces of data. So the first time that this would be called, the entire array would be passed, of which the first element would be the 0 at the beginning, and then would be the total number of pieces. And if we have more than one piece, so if n is greater than 1, then what we do is we figure out sort of the halfway between point for the array. And what will happen is we'll call recursively this merge sort. So this will deal, yikes. This will deal, this will deal with the left half from first to n1, n1 being halfway through the array. Remember, this is integer division, so this is going to be a whole number. And then this piece here, this will be the call to the sort on the second half. So first plus n1 would be the beginning of the second part of the array for so many spaces. So we actually, in a sense, have like a double recursive call here because this is calling merge sort. This is also calling merge sort. Once the sort on the right is done, then the data is going to be merged together. So now let's just come back here. The idea is we'll sort the array on the left, sort the array on the right, and then we merge those two parts together. When we are doing the sort on the left-hand side, that gets broken down smaller again. So let's jump ahead, and we'll come back to this. So suppose this is the array that we want to sort. And so the initial call, data, this would be the whole, this is the data array. And in the initial call, so first would be 0. To represent, this, these indices, 0, 1, 2, 3, 4, etc. So the first would be 0. And then the n would be 1, 2, 3, 4, 5, 6, 7, 8. N is 8. And so on that initial call to the merge sort, what we're receiving, let's back up here, I haven't gone too much in yet, is that for the first would be 0, the n would be 8, this would be the data array. And so given that situation where we do have 8 coming in here, 8 is greater than 1. So n1 would be 8 divided by 2 or 4. And n2 would be n, which is 8, minus 4, which is 4. And so then the call on the left-hand side, so first, remember initially we said that the first was 0. So 0 would be here, n1 would be the number of pieces of data. So this is actually going to call merge sort, but I just want to take a look at this, the second piece first. So the first, which was 0 plus n1, so this part here is 4. This part here is 4, meaning that that's where we're beginning. That's going to be the first, and the value here is 4. So we're beginning in terms of this whole array. That first call to merge sort is being done, and so then it goes in and it will logically look at the left and the right, but what it's really doing is just going to do the call on the left hand side. So it's now going to say, okay, for the sort that we're in, let's sort the left hand side. So when we get into the merge sort, again, another instance of the merge sort, it looks at this piece of the array and says, okay, let's break it in half. We'll sort the left half and we'll sort the right half. So then for when it does the sort of the left half, it says, okay, well, since n is greater than 1, because n is 2 in this case, it breaks it in half. So then when it goes to call the sort on the left-hand side, well, since n is 1, it doesn't call itself. When it then does the sort on the right-hand side, n is 1, so it doesn't call itself. So now we're ready to do the merge. And what I'll just do over here on the side is think we'll have like a temporary array. We'll have a pointer on the left, we'll have a pointer on the right, and we'll have a pointer to this temporary array where we're going to be moving into. So then for what is being pointed to, we compare just those two values, which one is smaller. The 6 is smaller, so the 6 goes here, and then this pointer advances here. And so since we now did the 6 here, when we go to advance the pointer, we're out. There's nothing left on the right-hand side. Since there's nothing left on the right-hand side, the remainder of this array is then filled with what's on the left-hand side, which is the 8. So then this is the result of that merge. And so that these pieces here are in order. That was, before I clear the screen, what this is showing here is this part here. So when we're dealing with this instance of the array, we just finished the merge, or we just finished the sort on the left-hand side. We're now going to do the sort on the right-hand side. So the right-hand side, focusing now on the right, it breaks it down in two pieces. So when it goes to sort the left, there's only one piece, n is 1. Goes to sort the right, n is 1. So it'll create this temporary array. It's going to have a pointer on the left, a pointer on the right, and a pointer for the index here. For the 2 pointers that are here, it'll look at which one is the smaller. 5 is the smaller. And that finishes the right-hand side. And so the remaining on the left will fill in here. So we have our 5 and our 7. So now this right part of the lower 4 has now been sorted. So and just kind of showing again what we're in is that we're still dealing with the left-hand side. So here, so the left part had been sorted, the right part here had been sorted, and now we're ready to do the merge. So this is where this temporary array is going to be created. We'll have a pointer on the left, pointer on the right. We'll have a pointer for this temporary structure. So it'll compare in terms of what these are pointing to. 5 or the 6, 5 is less. So 5 comes in here. This pointer is now going to advance here. This pointer is now going to advance here. So it's comparing the 6 and the 7. The 6 is smaller. So 6 comes into here. This pointer advances. This pointer advances here. So now we're looking at the 7 and the 8. The 7 is smaller. So the 7 comes in here. This pointer advances. And then when this pointer advances, we're done on the right-hand side. So everything else on the left is larger, and so that will just fill in terms of this temporary array, the 5, 6, 7, 8. So this is the result of the merge of those two pieces together. Well, remember what triggered this whole thing? We were doing the sort on the left-hand side. Now we can do the sort on the right-hand side. Remember that initial call? The initial call to the array, our n was 8. And we broke it in half, and we said, okay, let's sort the left-hand side. Well, that sort on the left-hand side is done. Now we can do the sort on the right-hand side. So the sort on the right-hand side, break it down left and right. Then when it goes and sorts the left, it breaks it down left and right. There's only one piece here, this is sorted. Only one piece here, this is sorted. And so we'll create, and I'll spare the drawing right here, but this will be the merge of those two pieces. Then this right piece right here, we'll go and sort that. This is only one piece, so it's sorted. There's only one piece, so it's sorted. So we'll do the merge. We have our merge of our 1 and our 9. So now the left has been sorted, the right has been sorted, and now what we want to do is we'll create a temporary array. We'll have a pointer here, pointer on the left, pointer on the right. And so 0 is smaller. Of the two things that are being pointed to here, 0 is smaller. So 0, this pointer advances. This pointer advances. Between the 3 and the 1, 1 is smaller. So 1 comes here. This pointer advances. This pointer advances. So we have so the active pointers are here and here. So it looks at the 3 and the 9. The 3 is smaller. So the 3 comes here. This pointer advances. Now we're done on the left-hand side. So that means everything else on the right is larger. And so we get the 9 coming in. And so then there is the merging of those two pieces. And so now we're at the left-hand side is sorted. The right-hand side is sorted. And so now what we can do is the merge of these two pieces. I think the angle that I'm at is forcing me to angle this to the left. Sorry about that, but we'll have a pointer on the left, pointer on the right, pointer into our temporary place. So it compares the 0 and the 5. The 0 is smaller. This pointer advances. This pointer advances. The 1 is smaller than the 5, so the 1 goes here. This pointer advances. This pointer advances. Compares the 5 and the 3. The 3 is smaller, so this pointer advances. This pointer advances. 5 is smaller than 9, so the 5 comes here. This pointer advances. This pointer advances. 6 is smaller than 9, so the 6 comes here. This pointer advances. This pointer advances. 7 is smaller than 9, so the 7 comes here. This pointer advances. This pointer advances. 8 is smaller than 9, so the 8 comes here. This pointer advances. When it goes to advance here, that left-hand side is done. So everything remaining on the right-hand side, which is just this one piece here, that goes in as well. So then there is the merge as completed of those final two pieces. And so now the whole array is sorted. So peeking back at the code again, so this is the recursive call on the left-hand side. It's in a reducing manner because this n1 is smaller than n. Here's the recursive call on the right-hand side, also reducing manner because n2 is smaller than n. And then after both sides are sorted, then the merge takes place. Now the code could have been here for the merge. This was just put here separately. So this loop, as long as there's both stuff on the left and the right, so as long as both sides still have items, it's going to go through and compare those items. Once we get to this point, that means one of the sides finished. Only one of these two is going to run. Either take everything on the left or take everything on the right. Oh God, I'm at 1440. Okay, so recursion on a data structure breaks the data structure down into smaller pieces and deals with each smaller piece.